call, and fine business on the QRP. The signal report is only 5x3, but the audio quality is very, very nice, Paul. Very easy to listen to, and no problem at all.
Hello my friends, my name is Paul, Oscar Mike 0 Echo Tango, and today I'm very happy. I've got this little package from England, and what is inside? This is the SDR radio kit from Mike 0 November Kilo Alpha, and I'm very happy because I can solder things together and to make one functional radio transceiver, my own, of course. So let's go to solder and put things together, and let me show you how to assemble these things together and to make one your own or my own radio. So I hope you will enjoy. Okay, so let's look inside of the box. I want to see what is inside. All right, so we have some packaging. And firstly, we have here the metal box. Here we have the metal box with all parts. By the way, I ordered this metal box with the main board in one kit. You can buy this kit separately without the case. So this is the case. It looks awesome. Okay, and the side parts. Be careful because we have here the screen. Okay. Here is the main board. Okay. I don't touch much because I don't have a ground in my hands. So you see that the main board is completely populated with the circuits, parts and the other things. The processor is on place. We have to assemble this part of the band pass and the other things. Okay, so some knobs, screws and the other stuff like buttons from rubber, and components like buttons, earphone sockets, LEDs. The second bag with the wire for the coils and also toroids inside. Other components like BNC PCB socket connector, other ferrites and audio jack, relays. Okay, and the another list of the parts. Actually, right now I'm not sure about the instruction manual. I should go to mcHF Alpha website and download the documents with all this stuff what I need to build this radio. Instruction manual included. Well, so it's time to build this thing up. Okay, so before we start, we should read these documents what I found on the internet. Good construction notes by v.0.6.3 you can find on the internet. You will see the link below the video, and on the mcHF Alpha you can find the other instructions like low pass filters and transformer winding. This is very important to read before you start this project, working on this project. So, first of all, I will install on the board these RF parts. What you see here. First, I will start with the neon anti-static lamp, which is something like this, and the BNC connector like this, and then I will winding the toroids. We will start with these ones on top. It's the toroids 13, 17 and 21. Then goes to 14, 18, 22 and so on in rows. I see that there is no space for the anti-static neon. These two holes should be soldered from this side, but there is no space because of a large B and C connector. So I have to solder this neon on the back side of the PCB board. Okay, I used these two guides, what you have seen before. This is the low pass toroid winding guide, with the number of turns and the length of the wire. And the second guide, the low pass filter from Chris, with the picture of the toroids. I counted the turns on each toroid, and I made a drawing like this. This is my new guide with each toroid informations. On each toroid you can see the number of turns and the number of the coil. And this is the BNC connector, which means that you can see the PCB board this way, like here. And here on the upper side there's the same situation. There's the same numbers as you've seen in this guide. So I begin with the first 3 toroids on the upper side. This will be 22, 30 and 23 turns. We want 22 turns on toroid, so we need about 280 millimeters, but 22 turns should be more, so it could be about 280, maybe 6 millimeters. So we have to cut 286 millimeters. It's right there. Okay, I will check again the length. Okay, it's 288. So just a little more. So take the wire, toroid, and can make 22 turns. When the wire is going through the hole, it means that is the 1 turn. Number 2, number 3, number 4, 21, and 22. Okay, first toroid is ready. It's 22 turns, as you can see. Okay, a few more wire left. I cut this wire later. So let's go winding the another ones. Almost all toroids are finished, and now it's time for the last one. Here L24 with 8 turns. So I have here 115 millimeter long wire and the toroid here. You just need left about 1.5 centimeter of the wire here in your hands, and then tie the wire through the core. 1, 2, 3, 4. Okay, so all my toroids are finished, and just about 35 centimeter of the wire left. This is my reserve, so this is enough if you will want to make another maybe 22 turn or 30 turn a coil. It's time to attach this coil on the PC board. Okay, 6 coils are soldered to the main board, and now I continue with populate this board. We need remove the isolation layer from this enameled wire. Firstly, with sharp, I have a sharp knife, and very gently and carefully I have to remove this layer out from the wire. From all sides. Be careful to not touch these other turns, just this little piece of wire. Okay, this one is okay, this one is good. And now the second side. Okay, coil is prepared, and now I have to attach this coil on the main board. I have to turn it back. No, now it's better. And then solder this little coil on PCB. Firstly, I solder this pin. And then turn back. Now the second pin. Okay. Good. Coil is there. Now we have to find a place for this coil. Oops. I see that I soldered this coil backwards, because here the red color and this is the black color. So maybe I should remove the coil again and solder it, or maybe I leave that. Okay, now I have continued to solder these things. And the final toroid is finished, so we can attach this toroid on mainboard. So Okay. Finish. Low pass filter is ready to use. And now, when the low pass filter is finished, it's time to check the continuity. On the back side, I have to remove the pins. Okay. It's okay. Okay, so here I have two toroids and the wire for the SWR and power meter bridge. So by this manual we should make our winding two toroids with 10 turns and just one turn as here described. So it will be just one turn and 10 full turns on toroid, and this will be a 10-to-1 transformer, and we should make them two of them, and this toroids will be attached here on these places. Okay, so now it's time for SWR and power meter circuit. We have two toroids in the bag, and I coated the 4 wires. 2 will be longer, 2 will be shorter. The shorter ones will be for 1 turn, and this longer will be for 10 turns. I prepared also the SWR power meter bridge toroid windings guide, and you can see that these toroids are 10-to-1 ratio transformers. Each transformer has 10 turns and 1 turn. The length of the wire for 10 turns will be 235 millimeters, and 1 turn will have 21 millimeter length. And here below you will see the diagram how to winding, because there is some difference between both toroids. The T3 T3 will begin winding from below of the toroid clockwise 10 turns, and the T2 will begin winding above toroids counterclockwise 10 turns. 1 turn will be here in the middle. So let's start with toroid T3. Begin winding below toroid clockwise 10 turns. One turn. Two turns. 3 turns. Four, 9, and the last number 10. Let's count again. So we starting from below, right here. So we have number 1, number 2, number 3, number 4, number 5, 6, 7, 8, 9, 10. So we have 11. Maybe here. All right. So now it should be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 turns. 10 turns, and when we look at the diagram, this is the T3, so this upper is winding from below and ending from above toroid. It's okay. And same thing, but reversed. We have to winding this second toroid, T2. We should start from above the toroid. And again, number 1, 9, actually it should be 10 because the first turn is counted right here, second, third, 4, 5, 6, 7, 8, 9, 10 turns. So now it should be okay, 10 turns. We started from above, right here, and we ending from below toroid of 10 turns. We will need a 1 turn from each the wire here, and this turn will be just short, something like this. Yeah, this is 1 turn, and if I will solder these things here on the board, I will use this 1 turn right here in the middle, and here in this hole, and we have toroid. So here is the 1 turn, and here we have 10 turns around. The same thing with the T3 here on this side. Okay, here you can see the 1 turn, and I cleaned the pads, the ends of the wire, you see. Here, there is no isolation anymore, even here on the one turn. And the same was done on this T3 transformer. Perfect. Okay. So the first toroid is solder it. And now the one turn. And solder. Okay, toroid is soldered, is fitted right in this place. That's the T3 toroid, and soldering job is done very well. I just cut the left the wires, and now it's time for T2. Okay, and the second T2 is also on its place right here. The one turn here in the middle and 10 turns around, the same here. And soldering job is also done. So here you can see the back side, and I just have to cut these little wires from the back. Okay, and the SWR bridge should be finished. Okay, the next step will be the T5 transformer, and it is a very small transformer, as you can see here. The place for the T5 is here on the RF PCB board. So from supplied about 30 centimeters of wire, we should cut off about 10 centimeter piece, so about 10 centimeters of the wire we should cut here. Okay, we have 10 centimeter wire, and bend it to in the middle to form two equal parts. And about 2 centimeters long part twist. You can hear, you can see the manual instruction here. Let's see how small this thing is. So here is about 1 centimeter length, and then put this wire inside the small binocular core here. Put the wire in each hole like this. Okay. Now we have to make a first turn. This wire should go through the opposite hole, and this wire also into opposite hole. Okay, so now I have a 1 turn. Now, using the rest of the wire we have here, we do the primary. So we form the first turn, where the 1 turn in a binocular core is when a wire goes through the both holes and exits on the same side it enters. This is the 1 turn. And we need a 4 full turns from this wire. So the wire is going through the hole, then back to the other hole, this is the 1 turn of the primary, and we need 4 of them. I bend the wire like this. I hold this wire on place. So the turn number 2. Okay, this is number 2. Now will be number 3. So this is 2.5. This is number 3. And 1 more. And this is number 4, but it is very tight inside. It is almost full inside of the holes. I have to find some. Okay, it's there. 3.5 and 4. Also the problem with space inside. Oh man. Okay, I got it. So this is turn number 4, the final one. Okay. Now we have to check which wire is secondary and which wire is primary. I will do this test very easily with the continuity check. Now I have to check the continuity on this transformer. Firstly, I scratch the isolation layer on the wires. Yeah, it seems that's the secondary. Yeah, that's the secondary, and that should be primary. Okay, and that should not beeping between secondary and primary, should be quiet. Now it is okay. Okay, the transformer T7 right here. You need two windings. The primary has 2 turns and secondary has 3 turns. Prepare a little piece of tape here. You can see that. You can use this tape, for example, and do a marking here on one side of this core. That means, or this side means that this side is secondary with 3 turns. From this side will be 2 turns. From this side will be 3 turns. You will need it later. So we will start from this side, from primary, with 2 turns. Turn number 1. And turn number 2. So this will be the primary with 2 turns inside. It is beginning and ends on the same side. And now the secondary part. So we put the wire here. And now we need 3 turns from the opposite side. So push the wire into one hole. This is the turn number 1. Then 2. Turn number 2. And 1 more. Two and a half. And 3. So here we have 3 full turns. Tie the wire inside. Okay. So from this side there is the 3 turns and there are 2 turns. Transformer number 7 is complete. So when we are done with the T7 and with the T5, we can start working on the T6 transformer. And this is very special because we need to bend this supplied wire, complete wire, into pieces, into similar pieces like this. Yeah, same long. And now we have to twist them together, where the twisting occurs on regular 10mm intervals. Yeah, that's cool for me right now. So at least 10mm intervals. But how I can do that? Maybe I should mark every 10mm to know where I should twist these wires. Maybe I'm just wasting my time with this, but who knows. So I marked this wire. I don't know if you see that on the screen here. Yeah, you see these marks, 1 centimeter or 10mm. So I will try to twist both wires in these places. It's not so easy. It's not so easy so far, so I have to play with this wire more. We'll show you in a minute. Okay, so now push the newly formed wire through the core to make the first turn. So we have the wire and we will make, oops, other side. This is the bended side here, but we will push the other side into it. You see, the bended side I will hold in my fingers and make the turn. Alright, this is the first turn. And now the second turn. And back. Okay. So we have 2 full turns right now. Now cut the ends on both sides and scrap the ends and connect on mainboard. Now is the T6 transformer also ready to use. Now I solder T7 transformer . Now I will cut and I think it's perfect. Location of T7 is this way, so close to the B and C connector there are 2 turns, and opposite side there are 3 turns. That's the T6 transformer. Firstly I attached this transformer here on this place. You see the markings. We have to do continuity check because we need to know if there is continuity on the 4 wires. Check the wires on one side. It is okay, and the other side it is okay. Be sure that you cleaned the ends of the wire of the isolation. I did it. Very good. It's fitting fine. And now solder this thing. Okay, so my tiny T5 transformer is right now prepared to be attached on mainboard. So I did continuity test. This side is okay, and also the other side. This is okay, so now just put this little thing into the holes on board. It's so tiny. So leg by leg. Okay. Do you see that? Okay, now solder this thing. Okay, it's done. And now put the wires. After my work, I will clean the board. So this tiny ferrite core is the RFC8, and I will use 8 turns of this supplied wire. The place for this turret, for this core on the board is right next to T6 core. It is here. It is in the PA section of the board. Okay, and 8 turns. So this is turn number 1. Number 2. Seven. And the last turn, number 8. Okay, I will try one more. Yeah. Number 9. Okay, 9 turns. So you see, properly clean the ends of the wires. Okay, and now yeah, that's the place. Okay, finish. Now I have all turrets and the ferrite coils on the board, and it's time for the other parts what I have in the back for the RF board. Okay, jack sockets. Okay, so the RF board is almost complete and a few parts still left. And this is the stabilizers for 8 volts, 5 volts and 3 volts. The U3 and U4. And the finals transistors. But I found a mistake here in the markings, because you see here this is the Q3 and Q4, but if you look at the board, so you will see that here is marked Q5 and Q6. So definitely not a Q3 and Q4. There is some mismatch, and I was looking at the schematic diagram, and you can clearly see that here is also the Q5 and Q6. But the type of the transistor is the RD16HF, and this is also here the RD16HF. So the same parts, the same transistors, but different marking. Okay, but before you go solder these parts on the board, we have to firstly mounting these parts on the heatsink. Here you can find these little holes in the heatsink on the case. By the way, this is the case what I bought with my kit from Chris, Mike 0 November Kilo Alpha. So firstly we have to install these parts here on this place to see how long legs you should leave and where you should cut the legs. So after installing with the thermal grease, we should attach the PCB board on this place like this, solder the legs, the pins from the transistors, and after that on the final cut their legs. And the last things what we have to do is solder this 30-pin header male for connection between RF and UI PCB, and also the speaker connection like this. The speaker connection is here on the board, so is the P7, and also the same speaker connection for heater you can see on the opposite side of this board, like here. See, that's right above, so the male comes down the male comes down and the female up. So I will solder the heater like first. Okay, that was the final pin. Heater is fitted in, so you can see here my soldering. I think it's okay. Good. And now I have to attach this little speaker connection. So after soldering the male speaker heater, you shouldn't forget for the female the opposite side on the UI board right here. Okay, this heater will transfer audio signal from UI board to the RF board, and then from the RF board here, from the bottom part, will go to the small supplied speaker, and I will use this wire with connector in the middle. So I will solder this wire here on the bottom of this board, and then directly to the speaker. Before we will install these components or solder these components to this board, we have to know what the leg lengths we need to solder in. And what we have to do is firstly attach these components to this metal case. And as I mentioned before, there are 4 holes, 2 on one side and 2 on the other side here. So before you will install these components to this case, use the thermal grease for better heat transfer between parts or transistors and this case. You have to use the supplied little screws, and after this installation we are able to put the RF board inside a box on this place, cut the legs and then solder them to the board. So you should attach these transistors or stabilizers in this order. So here will be the U3, here is the U4, and this is the Q5 and Q6. And in the same positions I will install this part. Before I will use the thermal grease, I clean the space or the place for components with, I'm using the pure alcohol. Apply the thermal grease. Now it's time for components. Okay, components should be straight up. And now I will try to attach the RF board on those places. We'll see if it fit correctly. You can see here that fitting's fine, and this one's also fine. So now we have to attach this board deeply until here, and then I will be able to cut the legs on the parts. After this is the best time to attach this little speaker, which was supplied in the kit, and also solder this wire. Have to clean that. Okay, nice and clean. And now I have to solder the wire on it. The red one on plus. Yes, it's okay. Before a PCB RF board installation, be sure that you connected this wire to the speaker, and here is the point. Connect the speaker, and now it is ready to pull the board inside this metal box. Now inside, it's getting very hard inside. You have to, it should click. Because here is this little screw or something, and here also. So you should pull the PCB board below this screw, and then the other side. Okay, you can see here how it should work. When the board is inside the box, you see that the legs perfectly match the holes on the PCB board, and the PCB board is touching this little thing, and also here. So the other side, same here and same here. And now I will show you how you can attach the upper board. Now I can cut the legs of the parts. And the other side. Now I will solder these pads. So components were attached and soldered to the PCB board, and also here on this side. Now it's time for the UI board, and attach the parts here and here. So I will begin with this 30-pin header on the UI board. And header is finished. Don't forget to use this thing, especially when we solder very close to the processor. Okay, so heater is there. I decided to attach these side connectors or side sockets. On this side will be the J1, J2, J3 and J4. These are these 4 sockets, and on the other side will be the USB connector right here. So this is my next job. And now the USB connector. okay. I will clean the connections after. And now the encoders. They are E1 to E4 right here, and we have to attach it here, here, here and here. And now the soldering job. So this is here, 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 and here. This is the LD2 and LD1, and the place for the LEDs is right here on left from the display. And you see here the LED2 will be the red one, so we'll show you. LED will be here, LED2 and LED1 will be here. If you're not sure how much you should cut from the LED, because there is some space between the board and the panel, I recommend to you slide this upper cover like this, and then put the LED inside, and then you should mark the position. That's the good position for me, so I will mark this position right above the leg on the bottom, so you can see now the marks, and I can measure I can measure this distance, or the length of the legs is precisely 8 millimeters, but you have to count with the thickness of the PCB board, which is 1 millimeter, and also you have to count with the about 1 millimeter more for soldering from the back side. So totally it could be, or in total it could be about 1 centimeter long legs on the LED. So I cut the legs about 1 centimeter long, and now we should be okay. And do the same with the green LED. And also mark the cathodes. Then you will really quickly recognize where you should solder, because here on the board you will see where should be connected cathode and where should be connected anode. Okay, so the red one on the right and green on the left. And now I prepare these little rubber buttons. I need to cut this rubber so for each button. So I will need something like this. Okay, buttons are cutted, and now fit the buttons inside the holes, and job is done. Good. So you see that? Yeah, it looks pretty nice. And now it's time for buttons. Push buttons S1 to S17. I have to fit the buttons right on the place I try it. But it's such a small thing and it's really hard sometimes. Okay, now it's much better. Good. All buttons are on places, and I will show you that after I finish the job. Job is done, finished, and soldering these buttons or switches took me about 20 minutes. Yeah, quite a lot of work on the buttons. Each button has 4 pins, and 2 of them are connected to ground and 2 of them on the signal. So it is quite a lot of work, but it's done, it's finished, and now the final thing, and it's the really final thing, is attach this on the UI board. But originally it should be soldered right to this board, but I don't want to solder this because I think it would be much better to be removable the whole display module. So when I should remove the module every time when I want, or to remove by some damage or so on, it will be much more practical to don't solder this module. So tomorrow I will buy the another heater or 2 heaters, and we'll solder these heaters here on the sides. So I just finished the UI board. It is completely populated by components. Instead of one component, this is the screen or display module. It's still not soldered onto board because I want to make a little modification on it. Today I purchased this header or headers. I have purchased them, 4 of them, and I want firstly to solder this header on board and then plug on it the display module. But before I will do that, I have to ensure that I will have enough space between the board, this module, and the upper plate of the case. Therefore, I have to firstly install the UI board on the RF board. I have to stack this board together into the normal position, and then measure and then make this modification what I want to do with the display. So now I will show you how I will stack these 2 boards each on the other. Okay, earlier in the beginning of this video you had seen that I had a little trouble with this neon lamp, because originally this neon lamp should be soldered from the other side of the PCB, but there was not enough space for it because there is a large BNC connector. So therefore I soldered this right here on the bottom side of the PCB board. Now I have a little problem with installing this shield, because you can see here there is no hole for this lamp. So maybe I should drill a little bigger hole or cut the metal or something, and then I can start to stack the boards. So here's the lamp. We'll measure this lamp. With pads it is 1.8 centimeters. So this is the 18 millimeters. And now I have to measure, or I have to mark the place on the shield. And the width of the lamp, that is about 7 millimeters. I will cut a little more. It will not perfectly fit, of course. There is some tolerance. Okay. So this part I'm going to cut out. Okay, and now I'm grinding it a little to make it look better. So now it looks much better. When you cut this shield, be sure that the shield will not touch any part or parts of your components or these legs on the lamp. So therefore I used a little more space around the lamp to be sure that there will be any shortage or something. Now we can continue with stacking PCBs in the case. You will need the screws and nuts what you have got in the package with the box or with the metal case, and in each corner you will need one long screw, one little screw, one larger or bigger nut, and two small nuts. First you have to use a small nut and screw it to the end. Like this. You can also use screwdriver to lock the nut on the screw. Now use the tweezers and pull this screw right here. Right here through the hole. And use the second small nut Wait, I have to remove this plate out. So again, it should look like this. Also, you can tie it with your hands, that's enough. You don't need to use any tool. Okay, now it is here also, and also on the other side. So now the screws and nuts are ready for the shield plate. Sometimes the screws gets a little off the axis, so you have to little pull the screws on sides and fit the shielding plate. Okay, now use the bigger nuts and screw it on top. And do the same with all of them. I will tie it very little bit, just a little, with my tool, and in this moment we can start the upper side. Here on top. The heaters have to lock, and also this one for the speaker. Okay, and I feel force, but I'm not sure. It looks like the force is coming out from these capacitors. Probably, yeah, there is a little hole inside, and this hole is not right on place, so maybe I should make a bigger hole, because there is still force. It's still not sitting right. Okay, so I have to definitely make a bigger hole here. Something like here will be here. And here also I have to make a bigger hole for 2 capacitors. And now I should grind this a little bit. Okay, this modification is finished. Yeah, it is not ideal rounded, but I think it's good enough for me. So let's finish this. Okay, so now second try. The shield with modification number 2. Here is the modification number 1. Let's see. Now we need the larger spacers or nuts to lock this shield. I think it will be tighten it enough. Okay, and now the UI board, speakerphone. Bravo, excellent. Excellent. It is everything fine. So now use the smaller screws. These ones. Good. So, stack of 2 boards is complete, and the final thing, the modification of the display. Now I have to check if I attach these little headers on the display, if there will be still enough space to close the upper plate of the shield. You see that this is now more larger, so yeah, it is definitely. So now I will try to use the upper shield without buttons. I don't need buttons now. Okay, so I see that it is not enough space. It still needs about when I close the shield as possible, it still needs, let's say, 2 millimeters. It needs 2 millimeters. So I should have a modification on the heaters, I suppose. Maybe I should cut the heaters from the upper side to be more flat. But 2 millimeters, yeah, it will be very critical, but I will do that. Okay. Yeah, I think it's narrowed. Okay. Compared to this one, suppose about 1 millimeter less than original. I will try this one. Okay, the female header is okay, but I also have to cut the pins from the board, so I will mark these pins, and then I will cut them. I'm still not sure if this modification will work. Okay. Okay, so this is the last one, and you can use SMD tool to make the holes a little bigger, because now they are closed with debris. And also the pressure air. Okay, my display modification is finished, and you can see that I shortened drastically the pads on the display board, and also I shortened these headers. And now I will try how it will work if the top plate of the case will fit fine right now without much pressure. So you see here in detail, and this side. Okay, and it looks promising. I think so. Okay. Yeah, that is definitely much better. Just a very slight, very little pressure, but I think it's okay. Definitely okay. Good, so I'm very happy. So this display now is very easy to exchange to the another one. So now I'm going to solder these pins and then finish this radio. Okay, so all pins or pads are connected, and now is the final time to turn on this radio. Okay, seems buttons working fine. So the side plates and the last screw. And we are done. My homemade SDR transceiver. Let's turn it on. Okay, this is my modification number 2, and the little problem or cosmetic problem on this keyboard here on the upper side is the swell of the buttons. You can see here on the sides these buttons are perfect. This is perfect, but when you go to the middle, the buttons in the middle are almost completely flat. You see that? Yeah, I'm able to switch the buttons. They are clicking fine, but the swell is no. It's no swell over here. But if you go more to the side, there is a swell again. This is okay. This is smaller, and this is no. This is completely flat. So I think I should open this box again, and I should lift up the internal UI board, and the buttons should be okay. I think the UI board is not straight in line, but is a little bit like curved in the middle, so that's causing this problem. So I opened the case, the upper plate, and I have prepared for you the dimensions where I will to drill the hole for this little screw, which was there before the modification number 1. I have this spacer is made of the plastic and this little screw. Before the modification number 1, when I drilled these 2 holes, there was a hole for this spacer right here. But now I will drill this hole here very close to this one, and this will make a distance between the upper plate and this shield. So you can see here the dimensions. So here from the side it's the 8 millimeters length, and from this side it is 55 millimeters. So here will be the hole. And I use a little rubber as the second spacer under this shield. You see here is the little rubber spacer. So I will use it right here under this shield. I have a little hole here, same as here, and now the spacers. Okay. And now I will use this rubber on the back side of the plate, somewhere here. I have to find a good place because I don't want to make much pressure on the circuits or some components on this PCB. So I found out that this rubber spacer and the best spot for the backside of the plate will be somewhere here, and it is 25 millimeters from this edge. So I will clean this spot with the alcohol, and then I will use the dual-sided or double-sided sticky tape. I clean the rubber Okay, and I will use a little piece of tape. But I have lost somewhere here. Yeah. Perfect. Okay, so this is the second modification on a metal case for the mcHF Mike 0 November Kilo Alpha transceiver with the spacers. Now I will attach these things back into the transceiver and we'll see if it helps. Okay, so seems that my modification helped me a lot. I see that the swell on the buttons now is much better than before. You can clearly see the buttons on top of the plate. It's not as good as here on the side, but I think it's much better than before, and yeah, I'm happy. Sorry for these knobs. These knobs are not original from the box. I just used from my old supplies. I will find some better ones or nicer than these ones. Okay, so because of the mcHF transceiver kit doesn't include the microphone, so we can use also the Baofeng microphone. If you have some old one or broken, you can use it, but you have to do modification. I have here a broken one. This is here is the 2.5mm jack missing. So I have to cut this plug here in this place and replace it with the 3.5mm plug what I have purchased from a local store. This is the L type, which is good because it fits very well from the side of the transceiver. So the wiring of the plug you can see here on the schematic diagram. Which is also available on the internet, and the first pin of this plug will be connected to the microphone. The second pin will be connected to the PTT, and this is the ground. So let me do this modification. On the beginning we have to check the colors of the wires inside, which one is for what purpose, and we can open the mic box and see what colors are used for the mic. So you can see here that the mic is the red one, mic minus is blue, and PTT button is gold. So I suppose that the blue will be connected to the ground, red one will be connected to the end of the plug, and PTT button will be the gold one connected to the second pin of the plug. Cut the cable from the mic and open the cable and see the wires inside. So let's see what is there. So we can here see the red one, gold, green and blue. So let me check again. We need just the red one, gold one and the blue, and the green one we don't need. So I will cut this wire, and now I think it's ready to connect. Now put some solder on the wires. You will need just the heat of your soldering iron. You don't need to scratch these wires. And then we have to check the continuity on this connector. So the first pin is the center, the second pin is on the side, and ground is the body of the connector. Hook this cable here. Okay. Fix this cable inside the connector and then connect each wires you need. On the final, we have to fix the cable inside the connector to prevent moving the cable inside the connector, and to prevent break the wires. They are really tiny. So use your pliers and make sure that it is fixed properly inside. Okay, I think it's quite solid. So you see here that the wire is connected, just one left. It is the ground wire, which I will connect here to the body. On the final. Okay, I think it could work right now. We have to open the microphone box again, and we have to solder inside the 1 nanofarad capacitor to cancel the RF field in the circuit in the microphone. In the Baofeng microphone you can find this place here right near the microphone pads or pins. So we will connect here parallel to the microphone. Okay, you can see here capacitor is in. Now we can close the box and test the mic. So when the mic is ready, now you have to remove the UI board out from the case, because originally in this transceiver is missing the bias voltage for your electrode mic, and that's the resistor number R8 right here. I don't know if you see that here. Yeah, there is the missing resistor R8 is missing here. So that is the bias voltage for your microphone condenser. Okay, so you should, or you need to use 680 ohms SMD resistor. So let me put this resistor on, and then we'll see if the mic will working. And now it should be good. The voltage should be in and the mic should work. Okay, now when the microphone is complete and modification for the mic is also complete, it's the good time to connect this radio on battery, and I will connect this radio on my magnetic loop antenna here inside this room, and of course I will connect this microphone. Good. Turn on the radio. Okay, now I will turn my Zygo X5105, and we'll see what the audio signal coming out of this radio. CQ, CQ, CQ. Calling CQ, CQ, CQ. This is Oscar Mike 0 Echo Tango. CQ test, calling CQ. This is Oscar Mike 0 Echo Tango. Calling CQ. And now I will switch to the FM mode. We are in the FM mode. And now this is the FM test. FM modulation, FM test. This is Oscar Mike 0 Echo Tango. Oscar Mike 0 Echo Tango FM test, calling CQ.
Hello CQ17, Golf 0, Denmark, Japan, Quebec, calling CQ17, I'm by for a call.
Oscar Mike 0 Echo Tango QRP. Ocean Mike 0 Echo Tango QRP.
Ocean Mike 0 Echo Tango, I think it was, stroke QRP. Very good afternoon, thank you for coming back to the call. My name is Mark, Mike Alpha Radio Kilo, location central region of the UK. I'll give you a report on the next over. Oscar Mike 0 Echo Tango, Germany 0 Delta Juliet Quebec, over.
QSL Mike, nice to meet you, good morning. Golf 0 Delta Juliet Queen, Oscar Mike 0 Echo Tango QRP returning. My name is Paul, Papa Alpha Uniform Lima, and you're 5 and 8. your 5 and 8 QRP transceiver is the mcHF transceiver, the SDR radio from Mike 0 November Kilo Alpha. It's the homemade SDR transceiver, and I'm running only 10 watts in this moment. 10 watts into a long wire antenna. Back to you, Mark. Golf 0 Delta Juliet Queen Oscar Mike 0 Echo Tango.
Yeah, okay. Well, many thanks for coming back to my call, and fine business on the QRP. The signal report is only 5 by 3, but the audio quality is very, very nice, Paul. Very easy to listen to, and no problem at all. I'm running a little more power here. I'm running 300 watts into a 10 element 5 band beam, so that's possibly why my signal is a little greater. But lovely audio, Paul, from the SDR there. Really is sounding very, very nice. QSO. Hello, Paul.
Hello, Hugo. This is Oscar Mike 0 Echo Tango QRP station. I'm recording this video for my YouTube channel, Hugo. Hope you copy me good. This is QRP station, only 10 watts. Back to you, over.
Yeah, okay, Roger, Paul. Good morning. Oscar Mexico 0 Echo Tango. Oscar November 6 India Delta. Good morning, Paul. Well, with your QRP station, your 5 and 8, I just turned the antenna to your direction now. And you're really 5 and 8 here. Excellent copy with your 10 watt, Paul. I'm running at the moment 600 watt TS890 Sugar, as you know, ACM amplifier and the 9 element opti beam here, 25 meters above ground, Paul. Oscar Mexico 0 Echo Tango, Oscar November 6 India Delta.
Oscar November 6 India Delta, Oscar Mike 0 Echo Tango. Thank you very much, Hugo, for the nice report. I'm testing my new QRP homemade transceiver. I built the mcHF Mike 0 November Kilo Alpha transceiver. Maybe you know this SDR radio. And actually right now I'm running only 10 watts, and I'm running on the wire antenna, long wire antenna on my roof. So I'm very happy for this good report, Hugo. Back to you. What is my modulation, by the way? Over.
Yeah, okay, Roger, Paul. Oscar Mexico 0 Echo Tango from m0nka. Your modulation is good. Could be maybe a little bit sharper, a little bit more higher frequency, but it's very good understandable. So otherwise, it seems to be very good. And I repeat, your signal is really 5 and 8 here on the TS890 Sugar without any preamplifier. So the 10 watt and the wire antenna is working excellent.